Hey everyone, Sean at the MotoWorks here. I'm putting up a quick video to kind of explore the suspension properties of a motorbike that I saw on Facebook. So I pulled in this guy's picture that he put up, and as you can see here, it's got kind of, let's call it an unconventional monoshock setup. So what I wanted to do is kind of show you with without any kind of longhand math how this thing works, and maybe demonstrate some of the properties of this system that are not anticipated by the builder. So yeah, anyway, so I'm going to go ahead and turn the sketch off now that you see that I've got this system mocked up just based on the pictures, so we can guess it's pretty accurate, or accurate enough anyway for demonstration purposes. So what we've got here is our swing arm pivot. This arm here is going to be considered our shock. That's the length it is currently at with the wheel sitting where it is. Our swing arm length is fixed. The swing arm pivot on the shock is fixed in orientation to the swing arm. So you can see everything kind of moves the way it should. So the way that we're going to do this to initially demonstrate the wheel rate versus the shock rate, or it's the wheel rate ratio, I guess, is we're going to move the suspension in 1-inch increments in compression, and we're going to look at the difference in travel of the shock. Okay, so without doing any calculus, it's basically finding your instantaneous ratio at any given point, because the way this system is set up, because you can see that the angle here changes. I'll even put the angle in to show you. So what you can see here is if that angle changes, then your ratio of your wheel movement to our shock movement is also going to change. And there's reason for that, and then, I can draw it out mathematically. We could probably write a nice equation, to give you the differential of, this here based on the displacement here. I'm not going to do that because it's not going to demonstrate anything clearly. So what I want to do is take a look at your first measurement here. I'm going to write it down, and then I'm going to show you with a calculator exactly, how things work. So we got 6.364 inches at the start, and we're going to move this up 1 inch and record that number. So 6.110. Move it up again, 5.868. Move it up again, 5.639. Move it up again, and we have 5.425. And most suspension is somewhere in the 4.5 to 5 inch range of travel. So this is 1, 2, 3, 4, 5. Pretty close for our purposes. 5.229. All right. So good at calculus, bad at arithmetic. So I'm going to take and find the difference between our first shock lengths. So 6.364 to 6.110. We have a difference of 0.254 inches. And then the next one, 6.110 to 5.868. is 0.242, and then 5.9868 to 5.639, 0.229. Now, if you're noticing what's happening to these numbers, if you're paying attention, you're seeing that they're decreasing. All right, we're going to do the last one here. All right. So if we look at all of these numbers, okay, 0.254, 0.242, 0.229, 0.214, 0.196, each one of those numbers is the difference between the shock length at 1-inch intervals. So what that's telling us is when this shock, or when this swing arm moves from neutral position to 1-inch compressed, it moves the shock 0.254 inches. Okay? And the way springs work, they're basically, the K factor is constant. All right, so for every inch I move the shock, it's going to resist with a force proportional to the displacement. Right? There's no non-linearity there in most cases, so we're not going to concern ourselves with that. But what we saw, okay, from here to here, the shock moved a 1/4 of an inch, 0.254. From here to here, the shock moved 0.242, less than a 1/4 of an inch. And then up here, 0.229, even less. And then 0.214, even less. 0.196, even less. Okay? So, each one of these increments is 1 inch. I move the wheel 1 inch, the shock here moves 0.254 inches. So our lever ratio is about 4:1. Okay? Does that make sense? So 1 unit of force being applied here is equal to 1/4 unit of force here, or 1 unit of force applied at the swing arm is equal to 4 units of force up here. Does that make sense? I hope it does. Now, when we get up here, even further compressed, our ratio is 0.196. So for every 1 inch of movement, we're only moving the shock 0.2 inches. The force ratio is now 5:1. Okay? So 1 unit of force when this thing is compressed is going to give us 5 units of force up here. That is what is called a regressive suspension rate. Okay? The more you compress it, the softer it gets. I'm going to repeat that for emphasis. The more you compress this, the softer it gets. The math does not lie. It's right here. Okay, if you want to argue with me about this, go for it. You can argue day and night till you're blue in the face. This is the math. All right? Now, depending on what your spring rate is here, and I'm going to guess based on most sport bike monoshock, units, you're probably at somewhere around 1,000 pounds per inch. Now, what that means here is that your wheel rate is going to be somewhere around 250 pounds per inch, which is probably pretty okay for a very light motorcycle, but that thing looked like a Harley. So it's a big motor. You want to consider that. Now up here, when your suspension is further compressed, you only have a wheel rate of 200 pounds per inch. So it's even softer. So what most people are going to try to do, because this thing is kind of soft, when they get on it, instead of getting your 30 to 35 millimeters of sag, which is recommended, you're probably going to be somewhere up here. So they're probably going to jam the preload down, until it hovers somewhere around here, but that doesn't change the spring rate. So all you're going to do is you're going to have a bike that basically isn't using the suspension until it hits a really big bump, because you're going to be riding on the preload. If that makes any sense to anybody, please, God, wish it would make sense to somebody. Somebody who's actually ridden motorcycles here. So I hope that demonstration helps. I mean, you know, this is not fudge here. This is real, okay? This is math. Math does not lie. So there you go. Dropping my pen. Deal with it what you want.